We are ready to do Unit 5, Lesson 3. We've already done in Lesson 1 adding and subtracting polynomials. Lesson 2 was multiplying. So Lesson 3, we would assume it would be dividing polynomials. But when it comes to dividing polynomials, that's not really what we call it. It's not called dividing polynomials. It is called factoring. All right, so factoring. So I'm going to skip over these warm-ups and we are going to talk about what is factoring. So it is separating a polynomial into smaller parts. Now I have two examples of polynomials here in simplest form. The first one I have is simply a number. That is still a polynomial in simplest form. How would I write the number 6 into factored form? So think about what you know about factoring. Most of you are familiar with a factor tree. How could you break down 6 into smaller parts? And that would be the same as 2 times 3. So 2 times 3 is how you could break the number 6 down into smaller parts. We can do that exact same process with a polynomial that includes variables using a factor tree. And so the final answer would look like this. It would look like A on the outside, and then 3A plus 7 on the inside of the parenthesis. And I want you to notice that if you tried to multiply that monomial times that binomial, it would get you right back to the simplest form. So it is just the difference of 2 times 3 is 6, or I can take 6 and break it down into 2 times 3. It's just going backwards and forwards with it. All right. If something cannot be factored, let's say the number 2, and you tried to do a factor tree with that, and you could only break it down into 1 times itself, then we called that prime. And we will sometimes see polynomials that are also prime because they cannot be broken down into smaller parts. Okay? So when we are factoring, there are several different methods that we use depending on the type of polynomial that we have. Today, we're going to start by factoring just using the greatest common factor. Okay? So, step 1, we're going to identify the GCF. Okay, we're going to check the coefficients for a GCF, and then we're going to look at variables for a GCF. So here's what I'm going to do. I'm going to walk through example 1 while going over step 1. Okay? So what I tell my students to do is to break everything down into smaller parts as much as you can. So in number 1, I see a 3, which is a prime number. So I'm going to leave it as 3, and I see an X. So I now can look at the parts I have. 12, I can break 12 down into smaller parts. I could do 6 times 2, or I could do 3 times 4. I want to use 3 times 4 because of that 3 right there, and I know I'm trying to find something in common, so I want to use the set of numbers that has a 3 in it. So look at that. They both have a 3. So here, the GCF equals 3 because it's the only thing that they had in common. Okay? So here's what I want you to do. I want you to write your GCF in front and put some parentheses behind it. What goes in these parentheses is anything that you have that we would call leftovers. Okay, so I want you to think about dinner at home for Thanksgiving. Okay, if you have Thanksgiving dinner and you cooked more food than you could eat, what do we typically do with the leftovers? Well, we wrap them up and we put them in the fridge, right? So what we're going to be doing with our leftovers is wrap them up, and instead of putting them in the fridge, we're going to put them in parentheses and save them for later. Okay? So I have an X and I have a 4. And then in the original problem, there was a plus sign here. So I'm going to keep that plus sign. And that is my answer. Okay, good. Let's now look at another example. Let's do example number 4. Example number 4. So if I break these down, I'm going to kind of work up. 5 is a prime number, so I have a 5 and I have an X. Now let's look at the other term I have. I have a 30 for sure. How can I break down 30 so I can try to make a matching number to my 5? And the answer is 5 times 6 is 30. And don't forget the y, okay? So I have all these different parts. Now I'm going to identify what do they have in common. What is my GCF? I see a 5 and a 5. So my GCF equals 5. So I'm going to write that down here. And now I am ready to identify my leftovers and wrap them up. So I have an X in the front. I have a 6 and a Y in the back. And then, like I said, keep that original sign that separated those terms. All right. So I've got my GCF on the outside and I've got my leftovers wrapped up on the inside of a parenthesis. And that is how we GCF with polynomials. Let's take a look at some bigger examples. Let's do number 7. I'm skipping around again, okay? So 21 can be broken down into 7 times 3, and then don't forget that you have a C and a D. And then 3 and D can just come down. They don't really break down any smaller. And now I'm ready to find my GCF, my greatest common factor. That has a 3 and that has a 3. So that's my GCF. Now let's wrap up my leftovers. So I have a CD in the front, I have a D in the back, and the original sign was subtraction. So I'm going to keep that right there. Excellent job. Let's go look at number 10. Number 10 is a good one. So I have a 16 and I have a 24, and I want to try to break these down using at least one number in common. So what is the greatest number that you can think of that 16 and 24 share? And that would be an 8. So 8 times 2 is 16, 8 times 3 is 24. And then I want you to bring down everything else that you have. You have a B, and you do have a C squared. Whenever you have an exponent above a variable, I want you to separate those out as well. C and C. I want you to be able to see, physically see with your eyes, every single part that you're dealing with in each term, okay? Now we're going to try to find our GCF. So I see an 8 and an 8. Is there anything else that you see that they have in common? And I do. I see a C and I see a C. So I'm going to take out that C as well. So my GCF is 8C. And now let's identify our leftovers and wrap them up. I have 2 times B times that other C I did not use. 2BC in the front. In the back, I see a 3 and I see a B. And then the sign of the original problem was plus. So keep the plus sign there. All right. Excellent job. Let's come down and look at number 13 here. In 13, I see that 5 is a prime number and it has an x. And then 13 is a prime number and it has a y. So what is going to be the GCF of number 13? What do they have in common? Well, they have nothing in common. And I can't break them down anymore either. So this is one of those situations where I would say the answer is prime, because you cannot break it down into smaller parts. So the final answer to that is it's just prime. I can't do anything with that. Okay, so remember those prime notes were over here, and I did use the example trying to factor tree the number 2, and I couldn't do it, okay? So prime is when it cannot be factored. All right, let's do, let me just pick a big example to do out of these. So I'm going to do, okay, I'm going to do number 18, okay? So 18, and I want to break down the number 12. And I'm going to look at 12, 36, and 6 and think about a number that I could take out of all of them that would be the same number. And that would be a 6. Okay, so I'm going to take a 6 out. So 12 is the same as, and I'm going to write this over here. 12 would be 6 times 2. And then I've got A's. I have 5 of them. 1, 2, 3, 4, 5. And I have 2 B's. So I'm writing everything out. My middle term, if I made that be 6, then I would also take out, let's see, 6 times 6 is how I would get to 36. Okay, and then I have 4 A's and 3 B's. So that is those terms. I'm going to do the negative 6 up here. Negative 6 or 6 times 1. And then I've got 2 A's and I've got 2 B's. I am still going to try to find my GCF. Okay, so I'm going to look at all 3 of these terms. I see a 6 in all of them. Do you see anything else that they all have? Let's see, they all have an A, an A, and an A. Oh, that one has another A, and another A. How about B's? Let's see. There's a B in all of them. And it looks like they all have another B in common. Okay, so in this situation, my GCF will be the 6. I have an A in all of them, and actually I had 2, so I'm going to put them back together. And they all had a B, but again, they all had 2 B's, so I'm going to put them back together. So my GCF is 6 A squared B squared. And now I'm ready to find what were my leftovers. So the initial signs that I had were minus and minus, okay? So leftovers in the first term, I see a 2 and I see 3 A's, so I'm going to write A cubed and put them back together. In my second term, I see a 6 and 2 A's, so that's 6A squared. And then in my last term, all I have is a 1. That's all I have left, so I need to put the 1 there. Okay, and that is it. Now there is one more thing I want to add. If this had 3 terms, so let me write this note here. This has 3 terms. So then your leftovers must also have 3 terms. and your leftovers are up here. Remember, that also has 3 terms in it, okay? So this practice, when you do it, it will probably use more paper for you if you're writing everything out in expanded form. That way you can physically view it and circle every part that each term has in common. It's very, very visual this way. All right, and then let's do our one application problem for today. If the area of a rectangle is that binomial, what are the length and width? So let's think about the formula. Area equals length times width. I know that the area is 4x to the 5th y minus 8x cubed y squared. And I need to find out, what does that equal in 2 smaller parts? Okay, so what they're asking me to do is to factor that, factor it down. So let's go ahead and break everything up. Let's see, I have 4 and 8. So I know that a 4 can come out of both of them. So 4 times 1 and 4 times 2. And then here I have 5 x's. That's an x. And I have a y. And then in the second term, I have 3 x's and 2 y's. So now that everything is broken down, I can start circling what they have in common. A 4. Okay, so that's going to be the GCF. It always goes in the front. And then let's see, I see 3 x's here and 3 x's here. So it's going to be x cubed. And I see 1 y and 1 y. Some students say, well, this one has 2 y's. Why don't you take out both? And my answer to that is, this one does not have enough to take out. So if you cannot circle it in both terms, then you cannot take out. It's like asking me to borrow money and expecting me to give you some when I don't have any, right? We can't give what we don't have. All right, now I'm ready to do my leftovers. So our GCF goes first, our leftovers go last. So I have a 1 and I have 2 x's, so 1x squared. Here I have a 2 and a y, so 2y. And then that sign that was in between them here was a minus. So this sign will be minus. Okay, I got that from right there. And that is my final answer. Factoring is probably one of the most difficult things that we will learn this school year, and especially to date. So it is going to require lots and lots of practice. Again, your assignments that you can complete at home are not limited to 5 tries. Please feel free to keep going until you get it, okay? Until next time.